Hi, I'm Kevin Durden, and my project is comparing the strength of human and randomly generated passwords. Cyber attacks are becoming more common as our reliance on technology grows. The one thing standing between hackers and our personal information is a password, which means if we can have a safer password, we can have safer data. Many people use randomly generated passwords, but are they stronger than ones you or me could come up with? The hypothesis for this project was that when comparing the strength of participant and randomly generated passwords, then the randomly generated passwords will be stronger because they are more complex than the participant-generated passwords. The null hypothesis for this project was that when comparing the strength of participant and randomly generated passwords, then there will be no difference between the strength of passwords. To test the strength of passwords, I coded an algorithm that would cycle through all the possible combinations of a password and would then print out how many guesses it took along with other information, like how many seconds it took, and for batch runs, the number of guesses per second. Here you can see a video of my algorithm cracking passwords. This video is at 100 times speed as the actual experiment took over 70 hours. To collect participant passwords, I created a Google form where participants could submit sample passwords for me to crack. I would then enter them into my algorithm, wait for it to crack, and then I would record the number of guesses. For random passwords, my algorithm has the ability to run batches of random passwords without any prompting. I would let this run overnight and through the rest of the day in one case, and record the number of guesses for each password. My algorithm also has the ability to switch between different modes, which I used for the 5 different tests. In this picture, you can see a little how my algorithm works. It starts with the first character in the list, and then it moves down the list till it has a match. The more characters in a list, the longer it takes, which is why test 4, which had 62 characters to sort through, took the longest. Here are the results for test 1, which was a 4-digit personal identification number. As you can see, the randomly generated pens took longer to crack. This was one of only 2 tests to be considered statistically significant, with a p-value of 0.026. I was actually surprised by this result, as on paper comparing 2 random sets of numbers will be reasonably equal. I think the most likely reason for this difference is people often use their birth year for their pen, which begins with a 1, the second character tested by my algorithm. These are the results for test 2, which was just lowercase letters. As you can see, the random passwords were slightly harder to crack, though not by a significant amount. These are the results for test 3, which had lowercase letters and numbers. As you can see, the participant passwords took longer to crack, but this test had a p-value of 0.95, making this the least statistically significant test in the entire experiment. These are the results for test 4, which had uppercase, lowercase letters, and numbers. You can see that the participant passwords are significantly harder to crack. This test had a p-value of 0.02, making this test the most statistically significant test in the experiment. This last test was more to prove something personally, and this was the LRSD sample passwords, which are birth year, birth month, birthday, and then your initial. As you can see, it was neck and neck for which was harder, which isn't surprising since it's essentially a random date and initial. Just a tidbit, but the password of a student would take much less time to crack than the averages represented here, as my algorithm starts with 2015 and moves down through the calendar dates until it gets a correct date. I had lots of adults fill out this form, meaning their birthdays would weigh down the average. This did not affect the results of the experiment, however, as the randomly generated passwords I generated range from dates from 2015 to 1980. Here you can see the results for all tests. As you can see, test 4 took the longest, with both average values not even making it on the chart. Overall, participant passwords took longer to crack, though the average p-value for all the tests was 0.44, making this experiment extremely statistically insignificant. Now, if there are a few things I would do differently with this project, 1, the computer I'm running this computer on is very slow. It's not great, meaning I had to limit my passwords to 5 characters. As you can see, as the number of characters increases, the number of possibilities increases. And with an 11 or 12 character password, on my computer, it would take about 10, 20 years to crack one password, and I only had a few weeks. Here's a graph. You can see 5 is really right before it jumps up to 6, and then after 6, I mean, it's impossible. So I had to limit to 5, but ideally the limit would be at 8 or 16. Thank you.